machine learning and AI has become the new norm in the e-commerce and retailer implementations from an IT landscape perspective. In that context, I just want to go ahead and take you through in terms of the difference in the AI that is actually coming up. The three different aspects how the data gets deployed and data gets moved. For the first one, which is there is offline, what we call as offline, where there's a humongous amount of data. There is large amounts of data which is stored in the enterprise data warehouses and the data lakes, in the transactional systems, where the learning is done offline by crunching the data, and typically it gets into like petabytes of information. So that's where, like, for example, in this case, when Joe lives in Midwest and, renews Netflix each month, that information doesn't have to happen in real time, but the information is very, very important from a user behavior standpoint and user profile standpoint. Okay. So the second one, which is near real time. In this case, it's like sub-second response time, sub-second response times that is required, and the data that spans across hundreds of terabytes of information, wherein the important aspect is the information needs to get notified to the front-end system, which is actually serving and enabling the shopping experience per se. But in this case, as an example, Joe changed an email address or shipping addresses. You do want that to be reflected while it's actually showing up in terms of the shopping cart phenomena, right? So that's an important aspect. The third one, and which is a very important one, which we have been seeing so very, very prevalently in the context of Aerospike deployments, is the real-time experience of how the data gets used. This is in the case that you did talk about, Suchrita, is basically fraud prevention, recommendations while the user is actually online and then trying to go ahead and buy the goods. In this case, specifically, Joe is trying to buy 5 GPUs with a foreign IP address. You do want to determine whether it is a fraud transaction or is it not a fraud transaction. Sometimes it could be false positive as well. So you do want to go ahead and determine what type of a transaction is that while in line with the purchasing time frame. So which kind of puts the pressure on in terms of SLAs and the challenges, like I said, into sub-millisecond level, wherein it has a tremendous amount of experience in impacting the direct user experience, and the amount of data that you actually get into is tens and hundreds of terabytes of data. And here specifically what we have been observing as a trend is the more amount of data that is being put for use in terms of identifying these machine learning techniques and AI, the more accuracy it is. So that's the path that we have been seeing. And there is a significant amount of data that needs to move between these strategic operation databases and the traditional data lakes and the EDWs, where the data needs to be kept in sync. And these three velocities of the data that we have been observing so far in the context of AI and machine learning, right? And there's another important aspect I want to tie it back to the previous one that I talked about between the real-time and the spectrum of real-time and the offline. The AI also has been kind of categorized into two different aspects, which we currently observe in all our customers, which is offline learning and there is online learning. Offline learning is more in terms of, Joe's been updating these addresses and he's moved from one location to a different location. You want to go over and look at more in terms of what recommendations to be shown based on the zip codes that have been moved, etc. That can be learned offline. You spend a lot of time, from a computational perspective on the petabyte of data that is available and learn and score it. Once that is scored, the scoring model gets onto the front edge, wherein the scoring itself needs to be learned pretty quickly, like, for example, in the case of fraud prevention and how the behavior of the fraudsters are actually taking place. And at the same time, even from a personalization standpoint, depending on the clickstream data of the user itself. Any of these cases, the online learning, which is basically the real-time learning, and specifically what we are actually calling that as Hungry AI. And Hungry AI is an important aspect. And that is the change of the learning process is significantly critical in terms of the time response, which is basically, you got to go ahead and learn pretty much based on the behavior as it is actually happening. So that's the key difference that we see between the offline learning and online learning. Now, I want to present how Aerospike gets deployed in the context of online learning. specifically, right? This is a solution that we have, what we call as a framework that can enable the AI and ML decisioning engines. In the bottom, you can see the entire enterprise environment where the data is actually stored, which is a transaction data and lots of clean data that is actually brought in from multiple sources. That transactional data is can be brought into a high-speed database like Aerospike, which is operational, and then the plugins that you see in the orange color here, which is basically the framework that you could use to combine the streaming data, which can come in from multiple streaming engines like the Spark, Kafka, Flink, which is like in the case of fraud prevention, it's the card swipe data as the cards are getting swiped, or the card not present transactions when they get initiated. Using that streaming data in real time, combined with the transactional data, the historical data, and then feed it in real time to the decisioning engines like the AI engines, ML engines, or the CEP engines, the complex event processing engines, and then close the data loop in real time. Right. So this is a very significant pattern that we are actually seeing how Aerospike gets deployed in most of our customers from an e-commerce and retail standpoint.